Jai Hind to all. My name is Dhanshri Pariha, Assistant Professor, Department of Computer Science and Engineering, Ajay Kumar Garg, Engineering College. Today, I am going to deliver the topic Interconnected Network from the subject Computer Organization and Architecture. So, the content of this presentation include introduction, the buses, bus arbitration schemes, the types of buses and the arbitration schemes, and the visitor bus transfer. So let us start with the introduction. So what is computer organization and what is computer architecture? Computer organization is the way the hardware components are connected to a computer system, whereas computer architecture is structure and the behavior of various functional units in a computer system and their interconnections. So this is the block diagram of a computer system, a digital computer system. Here we can see we have two types of lines which is connecting all the blocks. One is the dotted line and another is these dark black lines. The dotted lines indicates the control exercised by the control unit, means the control signals generated by the control unit, and these dark lines indicates the flow of instructions from one direction to another. Like we are having 5 blocks in genuine digital computer, that is the input unit, the output unit, the memory which is divided into 2 parts, secondary memory and the primary memory, and then we have the CPU, central processing unit, which will be having further 2 divisions, control unit and arithmetic logical unit. So these dotted lines and these dark lines are actually the interconnected network, that is the connection between the different block units, and these are known as the buses. Input unit contains various input devices like mouse, keyboard, mic, etc. and output devices like printer is there, screen is there. So the main unit, one of the main unit where the storage is done in the computer system is secondary storage and the primary storage. Secondary storage is generally a hard disk which is very large in size, and the primary storage includes RAM and ROM memories, that is random access memories and read-only memory, whereas the RAM is used for storing the currently running task in the computer system, and it is a volatile memory, and the data exists in the RAM till the power is turned on in a system. As soon as the power is turned off in a computer system, all the content of RAM will got vanished. Whereas in the secondary memory, like hard disk, the data is stored permanently in the computer system and it cannot get vanished when the power is turned off. So these are the 2 major types of memory. Although we are having various other types of memories also in a memory hierarchy, we have registers, we have cache memories, we have then main memory, RAM and ROM, EROM, PROM, PPROM, and then we have hard disk, flash drives, magnetic tapes. And here we are having the control unit and the arithmetic logical unit, which compose our central processing unit. So control unit is composed of further 2 types of schemes. Either it may be a hardware control unit or microprogram control unit. In a hardware control unit, we have logical gates organized that is used to decode the instruction and to execute the instruction in a further stage. Whereas in a microprogram control unit, we are having a microprogram control chip, which is a programmed chip which is used to generate the control signals. Control signals, right? Reading controls, writing controls from this control unit. Now in ALU, the ALU will perform the various arithmetic and logical operation like addition, subtraction, multiplication, division, comparison operation, greater than, less than, equals to, not equals to, etc. So this all computation will be done by the arithmetic and logical unit. Arithmetic logical unit will composed of AND gate, OR gate, full adder, and a multiplexer which is used to make a selection out of all these components. So that is a brief description about the ALU. CU, memory unit, input unit and output unit. So these are the 5 major blocks of a computer architecture which is connected through the interconnected network known as buses. So as we know that the brain of computer system is CPU, Okay, and we have three types of buses. Now, what is a bus? Bus is an interconnected network. As I told earlier that the architecture of computer system is incomplete without the interconnected network, as all the blocks get connected to each other with the help of buses. So there are mainly three types of buses: address bus, data bus, and control bus. As their name is said, what is address bus? The address bus is the carrier of the address from CPU to memory systems. Okay, and what is data bus? Data bus is the carrier of data from memory to the CPU or from CPU to memory. So it is a unidirectional bus, whereas bidirectional bus, whereas address bus is a unidirectional bus. So it will carry the addresses of content from the CPU to the memory, as only the CPU will be capable of issuing the addresses. There is no other device in the computer system that will have that capability of issuing the addresses. So the initialization of address is done by the CPU only. Talking about the address bus, we are having the addresses in the power of 2, like it can be like this: 2 raised power 3, 2 raised power 4, 2 raised power 2. That will be 4 address lines, 8 address lines, 16 address lines, like this in the power of 2. Then we have a data bus. Data bus is a carrier of the data from CPU to the memory or memory to the CPU, and it is a bidirectional bus. Bidirectional means the data can process or can move from one direction to another direction. In both the direction, the data can be moved. Exchange of information between the CPU and the memory subsystem. Whereas we have third bus, which is known as control bus. In a control bus, the control signals are generated. These control signals are generated by the CPU as well as by the memory devices. And it is also a bidirectional bus which can move in both the directions. So whenever a input output device want to communicate with the memory or to access the information from the memory, how that communication will be possible? First, that input output device issue a request to CPU. For issuing the request, it will generate some bus grant signals to the CPU, and the CPU in revert will place a address on the address bus. Okay, and that address will be then sent to the memory unit for searching of content, which content is have to be being sent to the input output device, either your keyboard or printer. And when that address will be reached here in the memory subsystem, then then the content of that address will be placed on the data bus, and the data will be moved from this bus. It can be moved to the CPU and can be moved to the connected input output devices via data bus. Along with that, which kind of operation is to be performed? Either reading operation, writing operation, or only so that control signals will be generated by the control bus. These signals are issued by the CPU. Okay, and then the device will come to know whether the reading operation is to be performed on the memory or the input output device. So there is a code for that. That code will be flowing in a control bus. So address bus, I told earlier, will be of 8 line, 16 line, 32 lines, parallel single lines in the power of 2s. The CPU will read and write data from the memory by the unique addresses, by the unique location, and the output of that location of data will also a address on the address bus. Whenever the data is being shared from the memory to the input output devices, then data after execution need the storage again, and for storage again we have to issue an address and we have to place the data on the data bus and address on the address bus, and then the data will be stored in the this memory unit. As I told earlier, when the CPU fetches the data from the memory, it first outputs the address, and then after outputting the address, the data will be placed on the data bus, and the CPU will read the data from the data bus and execute it accordingly. And in control bus, we are having these control signals, reading signals, writing signal, bus grant signal, bus request signal, these all signals belongs to our control signals and will be placed on a control bus. So this is a brief description about the types of buses in the computer system, that is the interconnected network, address bus, data bus and control bus. Now next we move to the topic bus arbitration scheme. Now what is bus arbitration scheme? It is a procedure by which the active bus master accesses the buses and relinquish the control of it and then transfer it to a different bus seeking processors or devices. A bus master is a controller that can access the bus for a given instance. That means the bus arbitration is a scheme in which we have a one master, which is known as a bus master, whose task is to obtain the control of all the buses and give the control of that buses to the devices which are requesting for the control of buses. For example, if there is an input output device and it is requesting for a bus to be accessed, either address bus, data bus or control bus, first that device have to create a request. That request is being sent to CPU for getting the control of the buses. If the CPU will give the control of the buses, then that device will take the control of those buses and make the use of them. After that, when the device will completed its execution with those 3 buses or the usage with these 3 buses, it have to give back the control of these buses to the CPU so that these buses get free for further use by the other devices. And there is a scheme for doing this process which is known as the bus arbitration scheme. How these requests are generated and how the control are shifted from CPU to input output devices or input output devices to CPU again. So these schemes is known as bus arbitration scheme. So this scheme is of 2 types. One is the centralized approach and one is the distributed approach. In a centralized approach, there is a single bus master that will make the control of all the buses and the all other devices will share the buses accordingly on the permission or by the we can say by the command of that bus arbitrator, means the bus master. But in distributed scheme, there is no single bus master. The devices among themselves will decide which device is going to be the master for that particular execution, and anyone device can become a master in the procedure. So that is a distributed scheme. The centralized approach includes, the first one is the daisy chaining centralized approach. In this approach, as we see in the diagram, we have a single bus arbitrator, that is a master, and we are having the m number of devices connected in the network in a sequence. Here we have 3 signals. One is the BGT, that is the bus grant signal. BRQ, that is the bus request signal. And third one is acknowledgement signal. Now, how this process of bus request, bus grant and relinquishing these buses back to the CPU will occur. Now, as we see in this diagram, we have a master bus arbitrator over here known as a bus arbiter, and there are certain devices connected to this bus arbitrator like device number 1, 2 and m in a sequence, that is in a chain. Suppose the device 2 is requesting for the control of bus. So for requesting a device, it will generate a bus request signal and it will activate this line to 1, and this bus request signal from this device number 2 will get activated, and this request signal will go to the bus arbitrator requesting for the getting the control of the bus, whereas the arbitrator in response will generate a bus grant signal. So this bus grant signal is first given to the device 1. The device 1 will check whether it will require this control of buses or not. Since the request is generated by device number 2, it will wait till the device number 1 will transfer that bus grant signal to device number 2. So it will perform a check whether it will need the control of bus or not, even though it haven't requested any control of buses. Now, if it doesn't require the control of buses, it will transfer the signal next to the and make its value 1, and the device 2 will get the signal, bus grant signal, and it will then activate this corresponding line of acknowledgement that that the control of buses will be obtained by the device 2, and this acknowledgement in response is given to the bus arbitrator. Now all the buses are being occupied by device number 2, and the bus arbitrator is informed about this through the acknowledgement signal. Now when the device number 2 will complete its work with the buses, what it will do, it will be load down this bus request signal to 0, and this bus request signal when becomes 0, this line will be attached to the bus arbitrator and it will get the information that it will do not need any further control of the buses. Again it will turn the bus grant signal to 0 and device 1 transfer it to the next device. Again BGT will become 0 and device 2 will get a 0 signal, means the buses are now freed from device number 2, and in its response it will generate this acknowledgement to 0, means there is no control of buses by the device number 2 to the arbitrator. So when the arbitrator is giving any signal to the device number 2, an acknowledgement will be issued by the device number 2 informing the arbitrator whether it will be having the control of buses or not by turning it to 0 or 1. Now the problem with this scheme is that even though the device 2 is requesting for devices, the device number 1 is in an idle state, it is not requesting any buses, but the bus grant signal have to be go through the device number 1 and the device number have to perform the check for that, even though it is not requesting anything. So in this process a delay overhead will be attached, means there will be delay in the execution of the process, means getting the control of the buses. Why delay overhead? Because whenever the number of devices increasing in this chain, that delay overhead will increasing. As if the last device is requesting for the buses, that request have to be processed by each and every device which is connected in a chain in a sequence before that particular M device. That is the one problem with this scheme. The second disadvantage of using this scheme is that if one node get fail, suppose the node number 1 will get fail, what will happen if it get failed? The previous nodes which is attached to this will not able to get communication or not get communicated with the bus arbitrator, as the line will get problematic, and the way to perform a bus grant signal is by removing this node and inserting a new node in the place of that particular node, which is a very complex and time consuming as a not an economic it is a very costly thing to remove a device from the network and then inserting a new device, and the other devices get halted because of this sequence of connectivity. So these are the drawbacks of using the daisy chaining bus arbitration scheme, and the advantage of using this bus arbitration scheme is it's very simple structure architecture where there is no need of connecting the lots of lines with the bus arbitrator, and it is a very simple scheme, simple to form. So after daisy chaining, one more polling bus arbitration scheme is invented in order to overcome the drawback of daisy chaining. In this scheme, polling bus arbitration scheme, as we see here, we have the multiple devices connected over here up to n, as similar as the bus arbitration daisy chaining bus arbitration scheme, but the difference is we are having some polling lines. These are known as the polling signal or polling lines, which is not present in the daisy chaining bus arbitration scheme. We have the again bus request signal and the bus busy signal. Bus busy is a kind of acknowledgement again to indicate the controller that the bus is being occupied by the device or not occupied by the device. Okay. So here we are having these polling lines. Now what are these polling lines? These are the extra number of lines which is connected with each and every device. Whenever a particular device needs a bus, its unique polling address will be shared on these 3 lines. In this architecture, why I am taking it to be 3? Because this polling line size will be dependent upon the power of 2. If I am having 8 devices connected in circuit, then I am having 2 raised power 3, that is the 3 polling lines. Okay, and if I am having two devices in the network connecting the network, so I am having 2 raised to power 1 polling line like this. Okay, so this polling lines is always in the power of 2. Here in this architecture diagram, we will be having an example that we are having the 8 devices, 8 masters we can say connected in the network, and if we are having 8 devices, input output devices connected in a network, then we have 3 polling lines for that. As the number of the devices increases the circuit, the number of polling lines will also increase in the circuit. If I am having 16 devices in the network connected in the network, how many polling line I need? 2 raised to power 4. So 4 polling lines. And what are these polling lines? Which are having a unique addresses of each and every device, which will identify the device on the network. Suppose the device number 1 is having an address of 001. This will be having address of 010. It will be having address of something 101. Let assume like this. Okay, and the controller will be issuing an address on these lines, like it will be issuing 001. So this unique address belong to master number 1, and the master 1 will get activated in when it will receive it address from these polling lines, and it will generate a bus request that I need a bus, and then the request will be processed by the controller, and the control of buses will be given to master number 1. The profit of using this architecture scheme is that in this scheme each and every node is disconnected from each other. They are not connected in a sequence with each other. So if one node get failure, this master 1 got failed, then what will happen? There is no effect of that node on the other nodes. They will continue their functioning. Only the way is to resolve this issue is to truncate this node from the architecture. All other nodes are working independently of the node number 1. So that is the best point of using this technique. Whereas the complexity in the architecture is the number of polling line increasing as the number of devices in the line will increase. As I told earlier, it will be in the power of 2. If I am having 16 devices, I have 2 raised to power 4 polling lines. Okay, if I am having 8 devices, I am having 3 polling lines, and so on. So that will complex the architecture, and the number of lines also increases. Okay, when this master computer will use the buses, it will generate a bus B signal to be 1 when it will be occupying the control of the buses, and make it 0 when it will free the buses from its usage, indication to the controller. So this is the polling technique. So these two types of scheme belongs to centralized distributed scheme in a bus arbitration. Now next type of scheme for arbitration is distributed scheme. In distributed scheme, as I told earlier, there is no centralized bus master. All the devices have the equal right to get a chance to become a master. Now how it is possible? So there is one I can say a 4-bit ID number which will be belong to each and every arbiter. Like we have if 2 to 3 devices connected, they will be named as ARB0, ARB3, ARB1, ARB2. Okay, and they all is having their unique codes, and by using them, whichever one be the master will get the control first and occupy the same system as in the centralized. But the difference is any one of them will become master. The master in the previous schemes are fixed like this controller, but here all the master have the equal chances to become the major master of the scheme. That is a distributed arbitration in which all the devices waiting to use the bus and have the equal responsibility in carrying the arbitration process. Now next topic is register bus transfer. Now what is the bus transfer? The bus structure consists of set of common lines, one for each bit of A register through which the binary information is transferred, one at a time to the other. Now what is the register bus transfer? Whenever two register want to communicate with each other, or they have to communicate with the memory or CPU, the communication will not occur directly. So in between we have the buses which will carry the data, carry the information, and how that will be possible, that will be done with the help of register bus transformation scheme. As we see in this diagram, if the content of register R is need to be transferred to some bus, how these devices are connected, like we have register A, B, C and D, and they all are connected with the common bus. So one way of constructing a common bus system is with the help of multiplexer. Now what is a multiplexer? A multiplexer is a device having 2 raised power n input and 1 output, that is a mux. That is the information about the multiplexer. So in order to connect and to transfer the information from one register to another, we will need a multiplexer. Thank you and Jai Hind.